Hello and welcome back to Atomic Math. Today we're going to look at the basic properties of algebra. We're going to go through them quickly and then we're going to dive right into fractions. Okay, the first one is your commutative property. That is a plus b equals b plus a. So we can add things in any order. It doesn't matter. Associative. Same thing. If there's brackets involved, as long as there is addition, we can put the brackets wherever we want. So a plus b in brackets plus c is the same thing as a plus b plus c in brackets. All right, distributed. This one is important because we do use this one a lot. If you've multiplied something into a brackets, then you can distribute that across the brackets. So a times b plus c is ab plus ac. Inverse. We can always add the inverse of something. So a minus a is equal to 0. And we can do the same for the multiplication. If we multiply a by the inverse of a, we get 1. We can combine like terms, but what we can't do is combine terms that aren't alike. So in this case, 2x squared plus 3x squared equals 5x squared. That's fine. But if I had had 2x squared plus 3x, then I could not have combined those. It's like adding apples and oranges. Order of operation, super important. I think we've all overheard this many, many times. Brackets, exponents, multiplication and division, addition and subtraction. So let's use these rules, but let's dive into fractions. So common denominator, one of the most important concepts in fractions. We know that we must have a common denominator if we're doing addition or subtraction. So in these two examples, you have 2 over x plus 3 over x equals 5 over x. Or 5 over x minus 3 over x equals 2 over x. Because they share a common denominator, both addition and subtraction were fine. But what would happen if you have something like this? You can't just add them together directly because they have different denominators. So how would we solve that? We can add them, but just not directly. We have to convert them first. We need to give them a common denominator. So we're going to multiply the first term by y over y and the second term by x over x. And we can do this because y over y is simply just 1, and x over x is also 1, and we can always multiply things by 1. So we're not changing anything by doing that. So then we end up with 2y over xy plus 3x over xy. Now they have a common denominator. Now we can add them together and get our 2x plus 3y over xy. Now let's take a look at a common mistake. This example here is totally fine. So a plus b over c can be broken up into a over c plus b over c. But what we cannot do is this. A over b plus c is not equal to a over b plus a over c. Now, if you don't see that fundamentally, or if it doesn't make sense to you why it doesn't work, the best thing that I can recommend for you is to just try playing around with some numbers so your brain can see why it doesn't work, okay? Now, let's look at one other common mistake. This is oversimplification. So, in an example like this, we have 2x over 2y. Of course, we can cancel out the 2's and be left with xy. But what we can't do is this. 2 plus x over 2 plus y is not equal to x over y. Again, if it doesn't make sense or you don't see it naturally why that's not true, go ahead and play around with putting some numbers in there and see what happens. But believe me, it is true. Let's look at division of fractions. Sometimes this can look a little messy. So you might be given the problem with the division sign in between two fractions, or they might be stacked on top like they are on the right here. And that can kind of look a little messy to people. Most people are fine with multiplication, but the division seems a little bit too much. But in fact, all you have to do is flip the second fraction, and then you can multiply. So you notice that my bottom fraction, 3x over 1 plus x, is now flipped upside down, and I have 1 plus x over 3x. So now I can just multiply it out like normal. And of course, we all remember FOIL, where we can just follow those rules to get us to our final answer. Okay. Another thing about division of fractions. Sometimes people don't recognize what this is. So whether it's looking like that or like this, they're not seeing a second fraction, so sometimes they're not sure what to do with it. But you have to remember that you can always write any value as a fraction with 1 in the denominator. So for example, 1 minus x, well, that's just 1 minus x over 1. So now I have another fraction. So now I can write it in the way that the previous example looked like. and we can do our cross multiplication or flipping it and then multiplying it, and now we can get to our answer. So let's look at one last thing about fractions, and that is 1 over x is equal to x to the minus 1. This is important because next video we're going to talk about exponents. And just another example of that is here, 2 plus x over x can be written as 2 plus x times x to the minus 1. Sometimes you don't want to have a fraction in your equation. It's complicating it, and it's simpler to just look at it in one line. So you can often write it like this, as long as there's no addition down there and you just have a term. So if you're ready to stop struggling and start learning, and you want to build your own algebra toolbox, then go ahead and hit the subscribe button and join us for our next video, which is going to be on exponents.